This time I'm going to be talking about another little ESP8266 board that's available on the internet. Nets works, and I've bought one for a little project at home that I'm going to use. So it's a cabinet lock, and I'm just going to let you know a little bit more about this board because it's very, very hard to find information about it at all. There's very little information on the internet, so this is it. Alright, so here's the board after I've set it up and tested it. So the first thing that I wanted to talk about was the access of transmit, receive and ground on these TTL pins here, and this allows it to be programmed with your favorite software. I've been using Tasmota, so I wanted to be able to program it with Tasmota. These two pins here, it actually comes with a jumper on those, and that allows you to put the jumper on, and that pulls GPIO 0 down, which allows us to be able to program the board. Before I did try programming it, I put on my TX and RX lines and connected it up to a terminal monitor, and just cycled the power a few times to see if there was anything on it. It didn't look like there was anything programmed on it at all, as far as I could tell. So I proceeded with putting the jumper on, applied power, and then I was able to flash the device. Now, one very important thing is TX and RX pins that are labeled on the board, and they are actually screen printed there. So I just used my ESP01 programmer, this little fellow here, which I plug straight into USB. That capacitor is a little bit different because my original one fell off, so that cap does look a bit different from what most people's will look like as well. And then I just added on the DuPont wires so that I could connect up, transmit, receive and ground onto the networks board, and no problem, I was able to flash that. I needed to flash Tasmota Basic. So the other thing to discuss here is these three wires are the relay. So we got this is the common, and this is the normally open connection, this is the normally closed connection. The next terminal here is actually a 5-volt supply that comes from the front end power supply, which is handy because then you can use it for switching the input here. Now, the input, what I liked about this board, first of all, is the power supply is a wide voltage input. So I think from 5 to 16 volts, I can't quite recall, I'll find those details. But also the input, we have opto isolated input as well. So in this case, it's just a single relay output with normally open, normally closed contacts, but also the ability to monitor one input as well. So in the application I'm using it, I'm actually going to drive this solenoid for a cabinet door, and I'll put a little switch on there as well so that I can monitor when the door is open. I've just changed the orientation here just because it suits it a bit better with what I'm doing. So currently I'm supplying 12 volts into this side, and the reason I want to use 12 volts is because my little solenoid is needs to be driven with 12 volts DC. So in this application, I've got my 12 volts coming in, so this is positive and this is negative. So positive, I've looped positive wire and negative. So in this case, I've looped my positive around into the normally open side of the relay, and then the common, I'm actually driving the solenoid. The negative side of the solenoid, I'm actually going back into the negative side here. So even though it is totally isolated, I've effectively joined the inputs and output so that I can use the single power supply to drive the, we'll call it the ESP8266 side, and the output as well. Now the other thing that I was able to do is I'll have to draw up a little schematic and include it as well. But basically, to be able to drive the opto isolator, we need a ground line as well, and that's what this yellow loop wire is. So that gives us a ground wire for the input circuit for the opto isolator. And then that simply allows me to drive a switch. So I'll have a normally closed switch on this here. So you can see that blue LED comes on. So that's the input to the board. And that'll be with my door closed. As soon as the door opens, it will trigger my software as well. So actually this diagram helps me to explain much better about the opto isolator. So if we look at this diagram, this is a similar sort of opto isolator. So this schematic is not actually for this device, but it helps me explain how it works. So with the opto isolator, we have a basically an LED inside this device, which switches on a transistor to actually allow current to flow. So you can see in this case here, we need to supply some current to the LED, but the other side must be grounded for that current to flow. So basically on this Networks board, this is the ground connection to that opto, and this is the supply connection to that opto. And this one here is that 5-volt line that comes from the front end power supply. So then when I apply 5 volts to that input, you can see the LED comes on. And of course the input gets driven to the ESP. So that's pretty much it for the hardware configuration. It's pretty simple, one input, one output. Now this is how I set up the Tasmota software to monitor that input and to control the relay output. The other thing that's worth talking about is you can see that we've got GPIO 4 is my output to the relay, and GPIO 5 I'm using as my input, and I've called it switch 2 rather than switch 1. And the reason that is because I don't want the switch to control the relay. So I found the easiest way to do that is to use it in this fashion. But then I also need to enable a different mosquito or MQTT mode. So what I do in this instance is I use this switch topic. So if I call back on that and see what it's done, you can see that the switch topic isn't set to 1 or 0, but it actually has a value here of this licker, what I've called it as my variable. So what I'm going to do now is activate that switch again, and you'll see that the MQT command is actually the CMD licker, and you can see it's bounced a little bit, but that's actually different to the actual command for the so what I'm trying to say here is these are my switch values, and these are the values that control the power relay. So you can see that published value is different to this one here, and that allows me to run the input independently of the output. So here it is in action using mosquito commands to control it. So what I've done is I've used pulse time so that whenever I toggle the input, it just operates it for a few seconds and then releases it. So here's an overview of pulse time taken from the Tasmota wiki. So basically you can use it to pulse a relay and it will stay on for a period of time. That period is in multiples of 0.1 of a second. So if the value is 10 for pulse time, that equals 1 second. So here in my console for Tasmota, for my particular device, we can put in the command line pulse time. So this will recall what the settings are. So in my application here, pulse time 1 is 20. So basically that is 2 seconds that it stays active for. So if I click on my toggle, it will activate the relay for 2 seconds and then go back. So there's no need to set an on state and an off state. You're just pressing that toggle button once and then it's returning 2 seconds later.
So here's how it works. The solenoid's mounted up at the top there, and you can see it will always push past that. Very simple mechanism where the left door has to be closed first. And here's my little loop. So that goes into the solenoid, which will slide past at any stage and the door is locked.
Here's the solenoid in the open state, and you can see after the timeout period, it closes again. This is what it looks like behind the door. It's triggered, the timeout period happens, it closes again. You'll remember earlier in the video I talked about there being an input to the circuit so that I could monitor when the door is opened or closed. I haven't implemented this yet. Currently I'm just using it with the solenoid output control.